this video, I want to show you how you can easily learn an AI to play the Google T-Rex game. The last days, I saw a video from the YouTuber CodeBullet with the same topic but a completely different way to handle the problem. He rebuilt the game, which is pretty smart, but it takes time and it's not really generic. Based on Mario.io, you can find the link in the video description. I take the neuroevolution algorithm and translate them to C#. To understand how the neat algorithm works, I programmed the SharpAI project with Visual Studio 2017, as you can see in the background. The tool allows you to teach the AI in real time directly in the browser. The camera captures the desktop screen and the network converts the inputs from the game to keyboard outputs. In this case, it is the up key to jump over the obstacles. In the next step, I will show you how you can install SharpAI and run your own self-learning network. Go to the link down in the video description and download the content as zip file. Choose a folder to save and open the download with WinRAR or 7-zip. Unpack the content to your folder and open it. Open the SharpAI SLN with Visual Studio 2017 and click on Start to run the application. I really hope the project behaves in your environment the same like in mine. In the first panel, you can see the general properties of your network. To initialize a new network, set network type to neat, change width to 80, high to 60, population to 10, and switch mode to age sensor. Width and high define the camera size and in result of that the input size of the network. In pixel mode, it would be 4800 inputs. The mode age sensor reduced this amount to only 60. After this, click on New to initialize the network. I clean up my screen and get the T-Rex game in the Chrome browser. Switch on the camera and drag it over the T-Rex. And next, set down the frames per second to 16. This means we convert inputs to outputs 16 times in 1 second. In the opacity slider, we regulate the opacity of the camera background. Generally, I set it to 0.3. With the zoom slider, you can regulate the zoom of the camera. In this case, I set it to 0.8. The camera converts the captured image to binary. So in the camera table, you can define the fore and background of the captured desktop screen. I call the obstacles you can't hit as enemy. Things you can hit, I call it as friend. You don't have to do the next step at home, but for demonstration how it works, I define the background of the game as enemy. And you can see the conversation show everything as foreground. So I undone this step and go ahead. In the trigger column, you can define the keyboard outputs. In this scenario, we only need the up key to jump. If you define a wrong trigger, click on it and press delete on your keyboard. Finally, we have to adjust the camera perfectly to the view of the T-Rex. To do this, the game must running. Click on retry and to pause the game, click on the camera. Now, you can use the arrow keys on your keyboard to move the camera. Set the camera in the front of the nose of the T-Rex. For the right direction, it's a little more difficulty. I always try to find the point where you can see a completely straight line which separates the screen about 15%. Before we start, let us save the settings for later sessions. To do this, click on Save in the Property panel, choose a name and confirm the dialog. So, now we are ready to start. Click on Learn in the Self-Training panel. After that, a 3-second timer will start. Try to focus your browser window before the timer ends, like you can see in the video. The algorithm will immediately take the control and react to the inputs of the camera. Every new start of a network could be different. In this case, the algorithm reacts correctly, but that is not always the case. Over the camera panel you can see the score. As long as the camera captures motion, it will be raised. This is the basement of the optimization of the coast function. You can find more about the algorithm in the class netmario.cs. In this footage you will recognize that the T-Rex always fails on the mid-flying bird. The explanation is pretty simple. Until this bird, the algorithm processes a lot of same inputs. But suddenly there comes a new input he don't know. So one way to encounter this problem is a lot of more training or a different setup. May additionally output, for example, the down key. There are more problems I don't want to hide. You can't use your computer while training. You can't speed up the training. Later in the game it will become night. The camera could confound informations. Desktop capturing is always performance intensive. If you use a bigger camera, it's naturally that you need more performance. And finally, I developed this tool related to the T-Rex game. I'm sure that you can use it for another applications, but it is optimized for this game. After each training session, you can save your progress for the next time. So click on Save inside the Self-Learning panel and choose a path. To load a training session, click the button with the folder icon and confirm the dialog. If the community is interested, I can update new features over time. Feel free to use the code for your projects. Thanks for watching my first video. If you like it, please rate it.